Question 10. A student uses this apparatus to investigate the energy content of different fuels. This is the student's method. Pour some water into the copper can. Then record the mass of the spirit burner and fill. Measure the initial temperature of the water. Place the spirit burner under the copper can and light the burner. Stop heating the water when the temperature reaches 30 degrees Celsius. Then record the new mass of the spirit burner and fill. So the student repeat the experiment with different fields. Explain two variables the student should control to make this a valid test. Okay. First one, the student should control the volume of the water. Same volume of water. Okay. And another one, so the same amount of heat is required. And another variable that the student should control is the spirit burner. Is the same distance to the copper can. So for doing this, the same amount of heat loss occurs. The same amount of heat loss occurs. Okay. Then question B. In one of the experiments, the student uses ethanol as the fuel. These are the students' results for ethanol. So the initial mass is 38.52. The final mass is 38.29. Volume of water is 100 ml. Initial temperature is 18 and the final temperature is 30. So calculate the value of the heat energy Q in joules. So we have Q equal to mass times C times delta T. So mass will be 100 times C, which is 4.2, and the temperature change will be 30 minus 18. So it is equal to 5040 joules. Then question II. Calculate the enthalpy change or delta H in kilojoule per mole. Include a sign in your answer. So first of all, we have to find the number of mole. In this case, the mass of ethanol equal to 38.29 minus 38.52. I'm sorry, it should be reversed. 38.52 minus 38.29. This is the mass, and then divided by the MR of the ethanol, which is equal to 46. So it will be equal to 0.23 over 46. So it is equal to 0.005 mole. Then enthalpy change equal to the heat energy divided by the number of mole. So we have 5040 joules, right? So it is equal to 5040 divided by 1000 in order to convert into kilojoules, and then divided by 0.005. 0.005. So the enthalpy change will be equal to 1008 kilojoule per mole. And since this reaction is an exothermic reaction, so we have to put a negative sign here.